Hi, I'm Sean Gannon, and this is minutemath. And today we're going to learn about adding and subtracting polynomials, and we're going to simplify each expression. So if I was given this expression, 14p to the fourth power plus 11p squared minus 9p to the fifth, parentheses, minus, parentheses, negative 14 plus 5p to the fifth minus 11p squared. Okay. Well, from there, I want to see if each parentheses inside it can simplify. There's no like terms in either one. So now I'm going to rewrite all my subtractions to be added negative and distribute the subtraction sign. So we have 14p to the fourth plus 11p to the second power plus a negative 9p to the fifth. Then distribute the subtraction sign, subtract double subtractions, adding a negative, or adding positive 14. And then here we're adding a negative 5p to the fifth. Distribute across here, adding 11p squared. Okay, so now let's go combine our like terms and put our highest degrees first. Highest degrees I see is to the fifth power. So we have a negative 9p to the fifth, put a dot to show that I brought it down, and then negative 5p to the fifth. Next. From there, I have the next highest degree is fourth power, right? So I add a 14p to the fourth. I don't see anything else. So the fourth power. Then we go to the third power, don't say anything. Second power, I have a plus 11p squared. And the other one is just this other 11p squared. Two of them. I don't see anything else. P squared, nothing with p's. Constant left, just 14. There we have it. Let's double check everything went down. 4p to the 4p to the fourth, 4p to the fourth, 4p to the fourth. Oh, made a little mistake here. That 14p to the fourth should be 4. Oh, no, it's 14. It's 14p to the fourth. Sorry. Right, 14p to the fourth. I almost had a mistake there. 14p to the fourth is right there. Then we have 11p squared, negative 9p to the fifth, plus 14, plus minus 5p to the fifth power, and then 11p squared. Right there, fantastic. And that's why it's important to double check your work, because I almost thought that was a parenthesis, and it was 4p to the fourth, and I had 14 here, but in reality, there was the 1 there, okay? I just, for some reason, was thinking it was parenthesis, and I'm like, oh, I didn't transfer it right. But it turns out I did, but it's good to always double check that, just have those things in place. So now let's combine our like terms here. We have negative 9p to the fifth plus a negative 5p to the fifth is a negative 14p to the fifth power. 14p to the fourth, there's nothing else to the fourth power, so we have plus 14p to the fourth. 11p squared plus 11p squared is 22p squared, and we have the plus 14. Not 4, 14. And there we have it, our final answer here. Negative 14p to the fifth plus 14p to the fourth plus 22p squared plus 14. So let's recap. We're given our two parentheses there. I've made everything into adding a negative instead of subtraction and distributed the subtraction sign, giving me 14p to the fourth plus 11p squared plus a negative 9p to the fifth plus positive 14 plus negative 5p to the fifth plus a positive 11p squared. Okay. Then from there, I rearranged for my highest degrees first and combined the like terms. So we have negative 9p to the fifth plus a negative 5p to the fifth plus 14p to the fourth plus 11p squared plus 11p squared plus 14. That's 14 and not a 4. And so then from there, I also did the dot method and double checked my work to make sure that was actually a 14p to the fourth that I brought down. Then I combined my like terms, giving me my final answer, which is negative 14p to the fifth plus 14p to the fourth plus 22p squared plus a positive 14.